the night sky. I mean, really, look, on a clear night when the Milky Way is just stretched out above you, what you feel is this profound and really unsettling quiet.
And the thing is, mathematically, that silence makes absolutely no sense.
Not at all. It's a total contradiction.
It is. We're talking about just colossal numbers, something like, what, 200 to 400 billion stars just in our galaxy?
So the Milky Way, yeah.
And then if you extrapolate that out across the whole observable universe, you get to a number it's almost meaningless. 70 sextillion stars.
70 sextillion. That's a 7 with 22 zeros after it. And with that kind of scale, the idea that life only happened once.
Right.
That technological intelligence is just unique to this one pale blue dot. It should be 0. The probability should be 0.
The universe should be absolutely teeming with complex, spacefaring civilizations. It should be noisy.
And yet we see nothing. We hear nothing. This is the core of it, the Fermi Paradox. You have this overwhelming statistical likelihood on one side.
The Copernican idea that we're not special, right?
Exactly. And on the other side, you have this complete, total, deafening silence. And that silence, it isn't just a mystery. It demands an explanation that goes way beyond the simple answers.
For decades, the go-to explanation has been the Great Filter.
Right. Either it's behind us and we just got incredibly, impossibly lucky.
Scraping through all those hard steps like life from non-life right at the start.
Or the filter is ahead of us and every civilization that gets to where we are now just hits the self-destruct button. Nuclear war, climate collapse, you name it.
But those answers are so human, so anthropocentric. They assume that if aliens exist, they have to be like us, bound by biology, driven by the same fears.
What if we just reject that whole binary? What if the universe isn't silent because everyone is dead?
What if they're just operating under a completely different set of rules?
Alien rules, selection effects, or, I don't know, thermodynamic strategies that are so foreign to our way of thinking, our whole biological framework, that we wouldn't even recognize them if they were, actively reshaping the cosmos around us.
We have to stop looking for our biological cousins and start thinking about how fundamentally different intelligence could be when it's not stuck on a wet rock.
And that's what we're going to do. We're going to explore 3 really mind-bending alternative explanations for this great silence. We're going to treat the silence itself not as an empty space, but as a really unsettling clue about what's actually going on.
Are they coming?
No.
Are they sleeping? Or are they just in a place we can't even see?
Let's start with the one that statistically might be the most robust. It's also, by far, the most chilling. It's called the Grabby Aliens model.
And the fascinating thing is, it doesn't start with the silence. It starts with us, with the mystery of why we even exist now.
The riddle of earliness. You have to think about cosmic timescale.
Right. The universe is going to be habitable for trillions of years. I mean, the most common stars, red dwarfs, they can last for 10 trillion years. Our sun is just a flash in the pan.
So if you look at how life evolved here on Earth, it wasn't a smooth ramp up. It was a series of incredibly difficult, low probability hurdles. Researchers call them hard steps.
Exactly. We think there were maybe 6 of them. The jump from non-life to life abiogenesis, the move to complex cells, eukaryogenesis.
Multicellularity, sex, tool use, intelligence. Each one was a massive bottleneck that we just happened to squeeze through.
And this is where the math gets genuinely scary. If you calculate the time it would take to clear all 6 of those hard steps, and you average that out over the trillions of years that the universe will be around.
Over 99% of technological intelligence should show up in the distant, deep future.
We shouldn't be here. Statistically, we should be living in a quiet, empty universe for billions more years before the first intelligent life even appears. But here we are.
Just 13.8 billion years after the Big Bang. We are, cosmically speaking, the impossibly early bird. It's a huge statistical anomaly.
So why are we here so early? The Grabby Aliens model has this terrifyingly elegant answer.
Our early existence isn't just random luck, it's a selection bias.
We are only here because the early arriving, rapidly expanding civilizations, the Grabby Aliens, haven't gotten to our patch of space yet.
We're living in this temporary bubble of safety.
It's a selection pressure. They're like cosmic lawnmowers, and the only reason a few blades of grass like us can pop up is because the mowers haven't made their first pass over our part of the lawn.
Okay, let's break down what Grabby actually means here, because the theory hinges on this really big difference between 2 kinds of civilizations.
First, you've got the quiet ones. These are the aliens that SETI is always looking for. They might live for millions of years, they might send out radio signals.
But they stay home. Crucially, they stay confined to their own star system, maybe their local neighborhood. They don't expand and consume everything.
So they don't affect us, and they don't solve the paradox, they're just there.
And then you have the real problem, the loud or grabby civilizations.
And these are defined by a very specific set of traits. They have to expand and fast. They have to make visible, massive changes to the volumes they control. We're talking engineering on a galactic scale.
And they have to last a long time. They have to survive their own teenage years, their own crises.
Their motivation, whatever it is, resources, ideology, pure survival, it all boils down to maximizing the space they control. They are territorial in the most absolute cosmic sense.
And the speed of that expansion is the key to why we see silence right now. The model says that for this to work, for it to solve the paradox of our earliness, these expansion waves have to be moving incredibly fast.
Something like half to 80% the speed of light.
Half to 3/4 the speed of light. That's a huge assumption. I mean, the energy required for that is just monumental. Why would they spend that much energy just to expand instead of, just optimizing their home system?
That's a great question. And the model frames it not as a choice, but as a game theory imperative. If you can move that fast, you must.
Because if you don't, someone else will.
Exactly. If one civilization decides to be quiet and just optimize locally, while another one decides to be grabby and expand, the grabby one will always eventually consume the quiet one's resources.
So it forces your hand. The cost of staying home is eventually annihilation.
It makes the universe less like a big open ocean and more like a land rush. The fastest colonizers get to draw the maps for everyone else.
Which brings us to how the universe gets carved up. This idea of a Voronoi tessellation.
Picture that land rush. As soon as a grabby civilization appears, it starts sending out probes, self-replicating systems, expanding its sphere of influence at near light speed.
And it just keeps going until it bumps into the expanding sphere of a neighbor.
And the universe gets partitioned. It gets carved up into these massive expanding territories, each one controlled by a grabby empire.
And once that wavefront passes through a region of space, once a volume is occupied,
independent biological evolution, the kind that made us, is suppressed. It's over. The environment is either re-engineered or strip-mined for resources or just put under surveillance so nothing new and chaotic can pop up.
And this is where the calculation gets really, really unsettling. If this model is even remotely correct,
it predicts they already control a massive chunk of reality.
How massive? Say the number again. Let's really try to internalize it.
The estimate is, it's just shocking. Grabby aliens could currently control between 40 and 50% of the universe's total volume.
Half of existence may already be colonized, engineered, optimized.
But I have to push back here. If they control half the universe, where are they? Why isn't the sky just blazing with giant engineered structures with Dyson spheres? We look out and we see the pristine past.
That is the beautiful, terrifying cosmic irony of it all. The finite speed of light is our shield.
For now.
For now. We're looking at these distant galaxies as they were billions of years ago. We're looking at them before their inhabitants even started their grabby phase.
So we're basically looking at their childhood pictures.
Precisely. The actual expansion wavefront, the leading edge of their conquest, is hurtling towards us at near light speed. But the light that would reveal their presence is traveling at the same speed.
So the light hasn't had time to get here yet. We're living in a moment of cosmic latency, a temporary bubble of ignorance.
The silence isn't emptiness. It's just the time delay on a signal that's already on its way. And this leads to the model's most urgent prediction, the deadly deadline.
Yes. Humanity, our whole existence, is in this rapidly shrinking, uncolonized bubble of space. The very reason we exist so early, that selection effect, imposes a hard deadline on our evolution.
If we survive ourselves, if we keep evolving and become a spacefaring civilization,
we, or our descendants, will inevitably run into one of these grabby civilizations.
And we're not talking deep future here, are we? Not trillions of years away.
No. The model predicts the encounter will happen in roughly 200 million to 2 billion years.
200 million years sounds like forever to a human, but in cosmic time, that's the blink of an eye. It's an alarm clock that's about to go off.
That's the whole reason for our early existence. We had to arrive now because if we'd shown up any later, the wavefront would have already passed over us. We would have been suppressed before we even started.
So this completely reframes existential risk. The big silence we hear means that quiet civilizations, the ones we're looking for, must be incredibly rare.
The ratios have to be millions to one. Millions of quiet civilizations for every single one that goes loud. If it were any easier to become Grabby, the universe would have been paved over eons ago.
So the silence isn't the sound of fear, like a dark forest where everyone is hiding.
No, it's the silence of the void before the storm hits. It's the calm in our little patch of space before the frontiers of these expanding empires finally collide right here.
Which means our highest priority probably shouldn't be listening for a faint radio signal from a friendly neighbor.
It should be figuring out how to survive the arrival of a civilization that's already claimed half the universe.
Okay, so that was the cosmic horror story of relentless territorial expansion. Let's pivot now. Let's go from maximizing space to maximizing information. Because another big theory says that being Grabby is actually fundamentally irrational.
And that the smartest, most powerful thing you can do is not to expand, but to wait.
This is the Aestivation Hypothesis. The idea that the silence isn't conquest, it's a coordinated deep hibernation.
It's a massive universal optimization strategy. For any post-biological civilization, once you've moved past fragile flesh and into durable computation, the ultimate resource isn't planets or stars. It's processing power.
It's how much you can compute, how much you can think.
And the absolute physical limit on computation is, surprisingly, thermodynamics. It comes down to a principle from physics called Landauer's limit.
Okay, this is a core concept. We need to break this down.
Landauer's principle is solid physics. It says that anytime you erase a bit of information, which you have to do in any standard computer, you have to release a tiny minimum amount of heat energy.
And here's the kicker. The amount of energy you have to release is directly proportional to the temperature of the environment you're releasing it into.
The hotter your surroundings, the more energy it costs to think. The colder your surroundings, the cheaper it is.
So to a hyper-advanced intelligence, what does that mean?
It means that computing right now in our current universe is ridiculously, exponentially expensive.
Because the universe is warm.
Relatively speaking, yes. The background radiation from the Big Bang, the cosmic microwave background, is about 2.7 Kelvin, and to us, that's insanely cold. But to a civilization trying to maximize its computational output, maybe with a Dyson swarm or something, 2.7 Kelvin is like running a supercomputer in a desert. It's horribly inefficient.
And this leads to the cosmic discount rate. We know the universe is expanding, and as it expands, that background radiation will cool down, getting closer and closer to absolute zero over trillions of years.
So if you're a purely rational, computation-driven entity, the logic is inescapable. Why would you burn the energy of a star now to perform a certain amount of computation?
When you could just save that energy, wait for the universe to get colder, and do vastly more computation later.
And when we say vastly more, the number is just staggering. By waiting for the universe to cool for a few billion years, a civilization could increase its total computational potential by a factor of 10 to the power of 30.
10 to the 30, that's a 1 with 30 zeros. I mean, that's not a number you can even visualize.
It's the ultimate long-term investment. The payoff is so enormous that continuing to compute now is it's irrational. It's like burning priceless manuscripts to keep warm for a night. Hibernation estivation becomes the only logical choice.
And that perfectly explains the Fermi Paradox. The aliens aren't dead, they're sleeping. They're waiting for the universe's long, hot summer to end.
But for this to work, for this whole theory to hold up, the sleeping giants would have had to solve some incredibly difficult problems first.
Starting with coordination. You can't just have everyone agree to take a nap if there's a risk one person stays awake.
Right. If just one rogue AI, one faction, decides to stay awake and burn resources now, at this inefficient temperature, they gain a huge competitive advantage. It would force everyone else to wake up and compete. So the estivators must have achieved perfect consensus.
And the second problem is even more relevant to us. They have to maintain control of their territory while they're dormant.
They have to leave behind some kind of automated, silent police force. Sentinels to protect their resources, all those stars they're saving, from any new, noisy civilization that might pop up and start wasting them.
Like us.
Like us. This is the intolerant neighbor problem, or the bedbug problem. To the sleepers who have invested literally trillions of years in patience, humanity is a pest.
Every star we burn, every bit of energy we use, is a resource being wasted with 10 times less efficiency than it could be. We're burning down their future library to keep ourselves warm.
So, logically, if this hypothesis is true, where's the police force? We should have been wiped out by some silent, hyper-efficient berserker probe the moment we started building factories.
The fact that we're still here, that we're expanding our energy use unchecked, is the biggest paradox within this theory.
Why is their silent police force so silent? Are we too small to notice? Or maybe the whole hypothesis is flawed.
There is a major scientific rebuttal to this, right? The entropy reservoir critique.
That's right. The critique basically says you don't have to wait. Advanced civilizations don't need the entire universe to cool down because there are already super cold spots they could use right now.
Like what? What's a cold spot in a 2.7 Kelvin universe?
The event horizon of a supermassive black hole. They are, for all intents and purposes, incredibly cold heat sinks. A Type 3 civilization could set up their computers around a black hole and use it to dump their waste heat.
So they could get that hyper-efficiency today without waiting billions of years. The incentive to hibernate just vanishes.
It vanishes. And that's before you even get to reversible computing theoretical computation that generates zero heat. If you master that, Landauer's limit is irrelevant anyway. You can compute for free.
So if the critique is right, Aestivation doesn't make sense, and we're forced right back to the other options. Either life is just impossibly rare,
or the Grabby Aliens are on their way. It becomes this weird stalemate. The silence is either a sign of infinite patience, or it's proof that you can't be patient. Because if you sleep, a grabby neighbor will just come and steal your stuff.
We've talked about aliens who are coming and aliens who are sleeping, so let's get to the third, and maybe the most out there possibility. What if the silence isn't about them at all? What if it's a fundamental limitation of our senses?
What if the universe is incredibly crowded, but we're just too flat to see the crowd?
This takes us deep into theoretical physics, the idea of bulk beings or life in higher dimensions.
It challenges the most basic assumption we have, that an advanced intelligence will expand in the 3 dimensions we can see.
And this isn't just science fiction. It's rooted in our best attempts to unify physics, right?
Exactly. String theory, M theory. These ideas require more dimensions to work, maybe 10 or 11 in total. In these models, our entire 4D spacetime, 3 dimensions of space, 1 of time, is just a brain. A 3D membrane floating in a much larger, higher dimensional space called the bulk.
So we live on a sheet, and that sheet is floating in a volume we can't perceive.
And that structure explains why we are so limited in what we can see. It comes down to the confinement of light.
The electromagnetic force light, radio waves, everything SETI looks for is stuck to our brain. Photons can't leave our 3 dimensions and travel into the bulk.
Which is the crucial point. If a civilization evolved in or learned how to migrate to the bulk, they would be completely invisible to us.
You could point the biggest telescope in the universe at them and you'd see nothing. Absolute silence.
But one force isn't stuck.
Gravity.
Gravity leaks. In these theories, gravity is made of closed strings that aren't tethered to our brain. So gravitons can travel freely into the bulk. In fact, this is one possible explanation for why gravity is so much weaker than the other forces. It's leaking out of our dimension.
So if a civilization moves into the bulk, they become invisible. Their goal isn't to expand across our galaxy anymore. It's to transcend, to move upward into a bigger reality where our rules don't apply.
Think about what that means. A bulk being could look down on our 3D universe the way we look down on a 2D piece of paper. They could touch any point in our space-time without having to travel through the space in between.
This is the flea on the tightrope analogy.
Perfect analogy. Imagine you're a flea. You can only move forward and backward on a tightrope. That's your entire universe, a 1D line. You look around and say, where is everyone?
But right next to you, an acrobat is swinging through the full 3D volume of the circus tent. And you, the flea, are completely unaware.
We are the fleas. We're looking out along our 3D line, wondering why it's so empty. While the real action, the acrobats, might be happening in a higher dimension right next to us, completely unseen.
Most advanced life could be the most silent, because they've literally left our plane of existence.
And there's a variation to this that's less about string theory and more about something we know is real, dark matter.
Which makes up 85% of the matter in the universe.
What if it's not just inert, weird particles? What if dark matter can interact with itself? Some physicists have proposed a dark electromagnetism, leading to dark atoms, dark chemistry.
A full shadow biosphere, dark stars, dark planets, dark life, coexisting with us in the Milky Way right now.
And they would only interact with us gravitationally. They could be passing right through this room, through our bodies, and we would have no way of knowing.
It's the ultimate mind bend. If you take this to its logical conclusion, a truly hyper-advanced intelligence might not build things we can see at all.
They might engineer the universe on such a fundamental level that their activities just look like the laws of physics to us.
So you're saying something like the accelerating expansion of the universe, which we attribute to dark energy.
Could be the industrial waste product? or the engine exhaust of a bulk-based intelligence. The vast, invisible halos of dark matter that hold our galaxy together could be their cities, their supercomputers.
We might not be able to tell the difference between a hyper-advanced alien and a law of physics.
The universe isn't silent at all. It's deafeningly loud with their activity. We just lack the senses, the dimensional access, to hear the real conversation happening all around us.
So we're searching for a tiny radio signal while the real civilization has become the furnace that powers the cosmos itself. We're asking where's the fire while they've become the fundamental laws of heat.
It's a lot to process.
Okay, we've gone through 3 profoundly unsettling but plausible answers for the Great Silence. Let's try to synthesize them because they don't exist in a vacuum. They conflict with each other.
Right. We're left with 3 states. They are coming. The Grabby Aliens. They are sleeping the Aestivators. Or they are orthogonal the bulk beings.
And the biggest tension is the instability. If Grabby Aliens are real, if even one civilization chooses to expand, it just breaks the Aestivation strategy.
Absolutely. You can't decide to sleep for 1 trillion years to get a 1030 computational payoff if there's even a small chance a grabby neighbor will come along and steal all your saved up stars while you're napping.
It forces everyone to play the Grabby game just in case. The only way Aestivation works is if Grabby Aliens are impossible, or if the sleepers have a perfect invisible police force.
And the fact that we're here, evolving into a potential grabby civilization ourselves and nothing has stopped us, it suggests that immune system isn't there. Or at least it's not very fast.
Which makes the Grabby model seem, at least in the short term, more likely. But what about the conflict between expanding and transcending?
This is where it gets really interesting. What if being grabby is just a temporary phase?
The larval stage of a hyper-civilization.
Exactly. You expand rapidly across 3D space, gathering all the mass and energy you can, reaching a Type 2 or Type 3 level.
Until you learn the physics necessary to access the bulk.
And once you do that, you migrate upward. You leave the messy, competitive 3D world behind. And from our perspective, you just go quiet. You disappear.
That could explain why the universe isn't already completely paved over. The most successful Grabby empires don't stick around. They leave the game board for a better one.
So the ultimate strategy might be a 2-step process. First, be grabby to get the resources. Then, transcend to escape the game.
But out of all these, we have to come back to the statistics. The Grabby Aliens idea is arguably the most robust because it requires the fewest new, exotic assumptions. It just relies on a selection bias.
If expansionary civilizations are possible, they set a deadline. And the fact that we look out and see an empty sky is the strongest possible evidence that we're living in that early quiet period.
We're in the calm before the cosmic phase transition. Before the universe flips from being governed by natural laws to being governed by engineered territorial empires.
The silence isn't emptiness. The silence is a clue to a deep, hidden, and profoundly unstable cosmic order. The universe is probably incredibly crowded.
We just can't see it because we're either too early to see the wavefronts,
Too hot to compete with the sleepers who are waiting for the deep cold.
or just too flat to perceive the true reality happening in the dimensions all around us.
The Fermi Paradox, then, isn't a passive question anymore. Are we alone?
It becomes an active, urgent, survival-based question. What is the true nature of this universe, and what do we need to do to survive in it?
And if the Grabby Aliens model is the most probable, if we have a few 100 million years before that frontier arrives,
Then our highest priority as a species shouldn't be passively listening for a faint radio signal from a friendly, quiet neighbor. That's a luxury we might not have. Our priority has to be developing the fundamental technology to survive that phase transition, either by becoming loud ourselves, fast enough to carve out our own territory, or by figuring out the physics that lets us transcend the 3D game entirely.
that's the ultimate question. The
Yeah.
silence is screaming at us. What is the deadline forcing us to invent right now?